Hello guys, my name is Saurabh Sahu. I am a DevOps engineer, and we have Arun Kumar, who is a DevOps engineer too. And today we'll be going through some of the basic DevOps interview questions, and Arun will be answering us and helping us to get the basic gist of it. So should we start, Arun?
Yeah,
Yes.
let's go with the questions.
Okay,
Yeah.
sure. So the first question would be, can you explain like the basic concepts of continuous integration and continuous deployment?
Okay, CI/CD.
Yeah, CI/CD.
So what is CI/CD? So the full form is continuous integration and continuous
Deployment. Yeah.
So continuous integration is when there is a change in the code. I am changing, for example, I am changing the color of my website to green to blue. Okay. So now what it does, that need a installable build. So when I change something in the code, I save the code or commit the code, it immediately creates the build. So continuously, if 10 developers making 10 change, 10 builds are being created, and each one can test so I made the change. How I will ensure that change is working? So I have to test. In the big application, I am working in one part of the change. You are as a developer, you will work of other. I have to change my test my change code, right? So then continuous deployment is coming. So my code is built. When I write the code, change the code, save it, commit it, I have a new build. Now the new build is going to continuous deployment. It is deployed to AWS or Azure. Now I go and see my website. I see the changes happened or not. Okay. These all are happening continuously without what I am doing is changing my code, saving. Build, deployment happening automatically.
Yeah.
That is why CI, continuous integration, building, CD, continuous deployment is happening.
Okay.
And why it is important? Because if you want to be faster to your production, like you want to say tomorrow happy Diwali, like tomorrow is Diwali, you want to say happy, immediately you make a change, it goes.
Okay.
But previously it is like you have to do some changes in one system, you have to test in another system, then you have to install in another system. Now CI/CD makes your development faster. Okay.
So yeah. So now since you mentioned about integration and those things, so next question would be, what is version control and what are the basic 5 Git commands that you should be knowing to do this source code management?
Okay. So now we talked about CI/CD, where I change my code and I deploy my code every time. And what happens if I write a wrong code and I deploy it? Right? That is, so I'm changing multiple times. You are changing multiple times. So then we need to know which version should be in the production. Production means live, where the customers use.
Yeah.
So then I am doing some change. It is not working. I am doing another change, which is also not working. I am doing another change, which is working. Then this version needs to go to your production. So whenever I do the change, I no need to keep a folder. Okay, this is not working. This not. That is what this version control tool is very key in the CI/CD or DevOps.
Okay.
And as you mentioned, Git. The tools are many. GitLab and Git is our local tool. Even you don't have internet. Even you don't have a thing. You install Git in your local. You write your code. It will store in your local repo. And 5 commands. One is git clone. You are cloning your remote repo.
Yeah.
Right? And if you don't, if once you create a repo, then you can also. So once you clone the repo, now you're going to make some changes. After changing, you will say git add. So add the changes. Then git commit is saving to your local. Then you are saying git push
to the remote.
Now from your local it is going to your remote. Remote is where everyone is
like it's the main source of truth. Everyone is working in the local and pushing it to the remote, and from the remote it is being deployed to the production.
So that is why version control is important, and you have to know how to use the git commands, and there is git fetch, git rebase, and other commands. Where if you are local, your remote and your local is different, you have to make the git
to sync it up and make it align.
And there are other commands like git logs, git branch, where if you want to see the logs, what are the commit happened, or you want to change from one branch to another branch, git switch, git branch, you want to see the list of branches. So all the git commands, basically you have to be very familiar.
Okay. Now you can describe what is the role of containers in DevOps.
Good.
Yeah.
So now I said continuous deployment, right? In the previous, I am deploying. You are also deploying. I am deploying every time when I have a wrong code. Also, it is deployed. I am right code. Also, I am deploying.
Okay.
You are also deploying.
Yeah.
So now in the physical infrastructure, I deploy into many servers. So basically, when we deploy into SIT, UAT, production, or test, development, and production. Test is somewhere we deploy our code just to see my code is working. Then in SIT or integration testing or development phase, we see with all other systems, with database and other systems, it is working. Then it goes to the production.
Yeah.
Right? Why container is very key here? Now I do my build as an image. I deploy the image into a system where you also deploy image. Then we are not going to take more space in the infrastructure. And when I deploy to AWS, I need an image. If I want to deploy into Azure, I need an image. So I can choose whichever cloud I want to deploy.
Yeah.
So with container, you can make lot of deployments. Also, whichever container is passing your code, that container also have your environment variables. With that version, you can put into production also. Otherwise, what will happen? Say your code is running in UAT, your testing phase. The same code cannot work in production because production server is having some other configuration where it is not working. But image, already everything is in the image for your application to work. Same is going to a production. So there's multiple advantages using container. One is your space. Second is your application is working in this one, will also work in your production.
Okay.
Third is you can choose any infrastructure. You don't need to use PowerShell for Windows, no Bash for Linux. So your image can run in any container environment, and every cloud has the container environment. That's why container is very, very key going forward.
Our next question is, what is infrastructure as a code and how does it help in DevOps? Yeah.
So now I talked about deployment. So how I am deploying? I am deploying my container to my ECS, Elastic Container, or Kubernetes service, or Azure service, right? So when I deploy to ECS, Elastic Container Service, it also connected to load balancer. From the load balancer, it goes to API gateway or CloudFront. From there, user is using. In between, we have VPC setup. So it's not just I'm deploying my application to one Mac OS or Android OS. It's an entire architecture. Because when customer is calling my application, when 10 customer is calling, we have SQS, queuing system, right? So all this infrastructure blueprint need to be provisioned and also need to be destroyed.
Okay, yeah.
The key part of infrastructure of code is if you create everything manually, it takes 30 minutes. Then you destroy everything, it will take 30 minutes.
Yeah.
And it's a human interest. But infrastructure as a code, you create the infrastructure during my deployment with all this ECS or Kubernetes. Now put my application into it. Once I done with my testing, Terraform destroy. Or then within 2 seconds or 2 minutes, your infrastructure is cleaned up. So you can create your infrastructure as many times you want. You can also clean up your infrastructure when it's not required.
Okay.
That is why infrastructure as code is very, very important going forward.
Yeah, like it would also help us to, like the human error, we might miss some of the components while destroying, but when you do it via code,
you can also reuse the code. So what happens? You created everything. Now you want to create another account. You have to do everything manually again. Right? You have to run this code. It is reused.
Yeah.
Right. That's why it has many benefits. We can't say one benefit. So we have many
benefits. Yeah. Next will be, can you tell the difference between a monolithic and microservice architecture?
Yeah. So this is a lot of team. Monolithic was one big application.
Yeah.
Right. When you make a change here, you have to deploy the complete application. Like you said, downtime. Microservices, you think about Flipkart. You have a category where you choose the product. Then it goes to the payment area. Then you do the payment. Think these are three different: login, category, and payment. Three different microservices.
Services. Yeah.
So what happens? My login, I'm doing a change, and I'm deploying. But whoever is already logged in into my category, they will still be looking into it. Whoever selected the product to payment, they will be doing payment. But what I am changing is only my login part.
Yeah.
right? So this is the benefit of microservices. And there are some theory, people are moving from microservices to monolithic also. Why?
Okay.
Now I have 3 applications. I have to maintain 3 applications, and 3 applications are talking with APIs. Okay, so they use Spring Boot or some APIs, which REST APIs, which will talk. So there's a latency also. So when I select my cart, which a product, okay, I also need to do the payment. So the payment pages need to fetch the data. So if you have many microservices, if you are having a poor architecture, then microservices will fail. So monolithic is less to maintain, because I make my change, I deploy, I ensure everything is working. And operations is VC. But microservices, now this service is going down, that service is going down. Here you have more traffic, here I have less traffic, right? So this way, I think microservices and monolithic are based on your application architecture and application choice.
Okay.
This is good or that is good, we should not. What is required for
based
your
on the requirement
you should choose your
So next question is like, how do you handle the configurations and manage those in DevOps?
Configurations, what kind of configuration? Like
for this deployment, we make some configuration, we maintain some CI YAML files and those things. So those
in DevOps, 90% we do configurations in GitLab or Jenkins, or Jenkins use Groovy script. So if you are working with Jenkins, you will learn Groovy script, you will do syntax. If you use GitLab, you have YAML. But what they both are do same. They declare your stages. First is your commit source code, fetch the code from the source code. Then do the build. In the build stage, there is npm build or yarn build, or it can be Gradle build. So those commands will be there in the build stage. Then deploy stage will have your Terraform init, Terraform commands basically. Terraform apply, right? Terraform apply will deploy. So all this will be in one file where all are written as a script. So mostly nowadays it's YAML. Only with Jenkins it is Groovy, but more and more if you see Azure DevOps or GitHub or GitLab, they use YAML. So you have to learn those things, but it is very simple. If you know what you have to declare, then it is very easy. Okay, so configuration is more of declaring what you want to do with this application. You want to build, you want to deploy. If you want to test it, you have to write a stage called test, and you have to write the test script. So it will run the test script. If test is failed, deploy won't work. Okay. This is the condition. If test is passed, deploy will pass. It will deploy. These conditions are made in this configuration file.
Okay, cool. Now next question is like, what is the purpose of monitoring and having the loggings in our basically the services we develop?
Now when we say DevOps, the operation part of DevOps is make sure that your application you deployed is running, and it has been like if I access your application, the performance should be good. Right? So monitoring part where it collects logs for all the data. So I deploy my infrastructure using a code. And it is deployed. How will ensure whatever infrastructure is built is performing good, or whatever application is running is healthy? Then those things we come from the monitoring. So monitoring, logging and monitoring, you visualize that as a dashboard with some matrices. How much users is entering your application. This can be one metric, and you see this much users is using. Then how much capacity ECS is using, or your Kubernetes. So you can able to make capacity alignment.
Scale accordingly.
And your error and events is, if something is going wrong, then you need to find. So your log is the where you will find there is some error in this particular component, because you deployed many components. Your Kubernetes, your load balancer, and your VPC, where it's the issue is. So if you want to identify the issue and troubleshoot, that is very important. And with the new AI is coming, they're going to monitor and remediate the issues with AI. Okay, these tools which is like CloudWatch or Dynatrace, those AI can do it. But again, logging, who is setting the logging? from the application is the developers.
Basically.
Right. So from there we have to make sure we are doing a very good logging practice. So everyone understand the same language. So you log something with language says payment is failed. I don't understand. If it says your elastic load balancer is failed, I may understand, developer may not understand what is elastic. So there should be a standard way of logging and error codes, logging codes.
Yeah. Cool. Now next, since we talked about logging, next will be how do you ensure the security of applications, like how the security comes into the DevOps.
So we talked about DevOps, but there is something called DevSecOps. That is where everyone is talking. But there's no difference. What is difference is security always comes after deployment. Okay, your application is done, you deployed, it is running. Now hackers are trying to catch it, or DDoS attack. But security is also in your code. If your code has a bug where it allows the all ports, and that is deployed to production. Now I try to access your application from any port, it will work. Why I have to find it after deploy the code to the production? That I can find when you write the code
itself,
right? Before the build itself, I can find that is allowing all the port. That's why in DevSecOps, we are scanning this code as part of our build process. If the security checks are done, there is no vulnerabilities, then you will get the Docker image or a Docker build to deploy. If you are not, security is failed, you don't get your Docker build or your build part. This is the DevSecOps. The other securities of infrastructure and other things are there, but securing your code, and there is a lot of tools also like White Source or like SonarQube. A lot of tools are available which you can plug into your pipeline, or you have a lot of plugins OSPF or a lot of plugins which can plug into your
IDs as well
in your configuration file, YAML file, to do the specific scanning, and it checks the scan. Then if there is a vulnerability, then automatically your build fails. Right? So that is why security DevSecOps getting more popular now.
So the last question of the session, to sum up everything. So suppose there's a situation where you want to troubleshoot, and there's an issue in a significant error in a production environment. So how would you troubleshoot it, and what all tools that you will use to find the error and fix it?
So there are two things, right? So now when you say production, there is an issue in production and no one had to log in. Now to create a new production, it will take me minutes. Right, because you have a code, you have build already automated, you have Terraform, you have AWS, you deployed Azure, and you can make the users to use it, because previously in on-premises we don't have that option of infrastructure as a code. So now we see the benefit. So when it comes to troubleshooting, the logging and monitoring is the key part. And whatever we got alerts, based on the alert, we will also see that where it is affected and how we have to troubleshoot. So here what is very important to troubleshoot is not just looking at the issue, try to fix it. You also have to see how this problem should not occur in the future. Which is the root cause analysis of the problem. And your architecture should always have serverless, like ECS, Fargate, Lambda, API gateway, similar services, a container. So lightweight architecture, not too much dependent on to your network and all those things. If of course, if it's on premises, you also have virtualization, VMware and Hyper-V to do proper architecture, right? So when there is an issue, if it's an issue in application, you have to create a hotfix branch. And you have to correct your code, and you have to merge your hotfix branch to your main branch, and it goes to the production. So you have to follow the practices so that whatever change you made for that is also captured in the branch. Right? And it is merged to the main, so it won't happen in the future. That problem is fixed. Right? It can be also because of not properly tested. So when you are testing, you test with 2 users. When it is in production, there is millions of users using your application, right? So you have to use proper performance monitoring tools, like a JMeter or Lowcast. You can give like 1 lakh entry, like you can just enter a user number and it will hit your application. So proper testing also to be done before you go to the production. That is a part of your QA engineers, right? So
that is like So it's also the security things, as you mentioned, those things also come into the picture. Then the testing part, and then the operation logging and those things. So that is the overall.
So we now we covered from DevOps to CI/CD to security to testing to
Cloud,
right?
yeah.
So this knowledge a DevOps engineer should have.
Okay.
He should not have only knowledge about infrastructure. He should not knowledge only about application.
Okay.
Over the time, he should understand. Doesn't mean that I need to know all the classes and methods in Java. No.
Yeah.
If I know how to build the Java, right? How to with npm or with the Gradle or Maven build, right?
Yeah.
So if I'm able to build the Maven, I know to use the Maven commands. I can manage the Java applications, right?
Okay.
And then if I'm a Java developer, I know how to build the container, Docker build, and how to deploy my container. Then I get the overview of DevOps, right?
Yeah.
And as a DevOps engineer, we also helping the developers who have to write the code and operation team who have to fix, support the users or customers in it, make everything automated. When they commit the code, save the code, security part of our pipeline, it automatically scans, right?
Yeah.
Testing is also automatically done.
Yeah.
Deployment is also automatically done. What the developer will see, pipeline is passed or failed. If pipeline is passed, his application is deployed, and you have to check it is working.
Yeah.
If pipeline is failed, you have to see why it is failed.
Yeah.
Because of security or because of testing, you have to fix it. And same way for operation, if he gets a quality code, then operation problem will be less.
Yes.
If he get the poor code, then he will get lot of calls saying that this is not working.
Then again the logging things and those things.
So that's why DevOps is a practice with different tools. And as we DevOps engineer, not only DevOps engineer, even developers and the operations have to have a knowledge on DevOps. But DevOps engineer should specifically have the overall understanding of all the phases of your software. That is called SLDC, software development life cycle. So if you know all the process stages of your software development life cycle, now it is also SLDC, like secure SLDC, SSLDC.
Okay.
So like DevOps and DevSecOps, SLDC and secure SLDC, which also covers the life cycle of your security.
Okay.
Yeah.
So yeah, that was a really good session, and hope it cleared a lot of questions. So with that, we'll wind up the session, and thanks a lot, Arun, for clearing a lot of doubts.
Thank you for your questions. Thank you, guys.
Thank you.
Bye.